discuss lecture number 45 of module number 5. Contents covered in the previous lecture are storing a word in a memory and execution of a complete instruction. In case of storing a word in a memory, we have discussed how the data is stored into the memory from the processor. So in order to store a word in a memory, so it requires the data that is available in one of the processor register needs to be copied to the memory data register, and where the data that needs to be stored in the memory location, that address of that memory location needs to be copied in a memory address register. By placing an appropriate or the desired address in the memory address register, and our data is we can store it in a memory data register. So finally we need to enable the write control signal. So in order to perform a write operation means storing operation, so hence write control signal needs to be enabled. By doing this way, we can store the information in one of the memory location. So after that, we have discussed regarding execution of a complete instruction. So under execution of a complete instruction, we have discussed by considering an example. So that is add of R3, R1. So in order to execute a given instruction or one of the instruction in a program, that instruction needs to be fetched from the memory and it has to be decoded, and then operands needs to be fetched, and finally we can execute the instruction. So in order to do this, so we are going to make use of the address of the instruction where that instruction is stored in the memory location. That address will be provided by the program counter. Hence the content of the program counter will be copied to the memory address register, so that instruction can be fetched from the memory and it is copied to the memory data register. From memory data register, it is ultimately copied to the instruction register. So in order that is copying the information from memory and placing to an instruction register, this becomes the fetch phase. So once the instruction is fetched, it should be decoded. So after decoding, we will come to know where are the two operands in order to perform the operations. So hence the two operands will be fetched either from the memory or from one of the processor register, and once both the operands are available, the execution of an instruction takes place, and finally we can store the result in the desired memory location. So hence in the execution of a complete instruction, we have discussed two phases. One is called as a fetch phase and another one is the execution phase. So fetch phase means from the beginning of fetching till storing that instruction in the IR register, and execution phase comes with a point fetching an operand, executing that instruction and storing the result to the desired location. So these concepts was covered in the previous lecture. Contents covered in this lecture are execution of a branch instruction. So in this lecture we are going to study how exactly a branch instruction, if at all a program contains a branch instruction, so how the branch instructions can be executed. So we are going to discuss it by considering a sequence of steps. So how those steps are proceeded in order to execute the branch instruction. Learning outcomes. After this lecture, the students will have a better understanding of execution of a branch instruction. So this is the Bloom's taxonomy pyramid. So in this lecture we are going to understand how the branch instruction will be proceeded. So hence it is going to fall under the taxonomy level number 2. So before going to understand the execution of a branch instruction, so we will just brush up the contents of a branching. So branching means branch instruction transfers the execution of a control to the target address. So whenever we are executing a program, if at all we are going to come across with a branch instruction, so then it is going to change the direction. So the direction will be changed, that is we are going to move to a particular target address. So the execution control will be transferred to the target address. So from that location the execution of the program is going to begin. So there are two types of branch instruction. One is called as an conditional branch instruction and another one is unconditional branch instruction. So if at all in a program if we are going to come across with a conditional branch instruction, so then conditional branch instruction checks for a particular condition. If that condition is satisfied, then only it will move to that particular target address. So if the condition is not satisfied, it is going to execute the next instruction. So in case of an unconditional branch instruction, so it will be without checking for any condition. Default it has to go to the particular target address. So that is called as an unconditional branch instruction. So whenever in case of conditional branch instruction, so it will be checking for a certain conditions. So that conditions will be reflected in the condition code flags like N, Z, C, V. So where N indicates a negative flag, Z is zero flag, C is carry flag, V is overflow flag. So based upon the value in the flag, so it may branch to a particular target address or it may execute the next instruction after the branch instruction. So now whenever we are going for a branch instruction, so branch instruction gives a different path, that is it has to reach to the particular target address. So if it wants to go to a particular target address, then the content of the program counter needs to be replaced by the branch target address. So that is we are moving from the normal flow to the different flow. So here normal flow indicates that we will be executing the instruction one after the other in a normal sequence. So if at all we are going to come across with a branch instruction, so there might be a possibility that we will be moving to a particular target address. So that target address might be at some different location. So hence in order to, that is we are supposed to copy the new target value or the new target address from where the instruction fetching has to takes place. So that address will be copied to the program counter. So this calculation, that is placing a new value, will be done by calculating certain target address, that is target address needs to be calculated. So here the target address can be calculated by adding an offset value, say for example X, to the updated value of the program counter. So that is, so whenever we want to calculate the target address, we will be going in this direction. So that is program counter, updated program counter will be added by an X value. So PC becomes equal to, so PC plus X. So X is the offset value that will be added to the updated program counter and that value will be copied to the program counter. So this will be making to a particular moving, means when a program counter address is loaded with a new target address, then instruction fetch will begin from that particular address. So this is how we are going to calculate the target address. So now let us check out the execution of a branch instruction. So the execution of branch instruction is having certain number of steps, say for example 1 to 5, and even we have an actions that are going to carried out in each of the step. The first thing is that first of all let it be a branch instruction, so we need to fetch that instruction. So in once that instruction is fetched, we will come to know that whether it is a branch instruction. So once it is a branch instruction, then a new target address needs to be calculated and then the new target address has to be loaded into the program counter. So before fetching, we never come to know that that is a particular branch instruction. So once the instruction is being fetched from the memory location and once it is copied to the instruction register will be decoded. So once the decoding process is done, at the step number 4 we will come to the point that whether that instruction is a branch instruction. So if at all it is a branch instruction, whether it is a conditional branch instruction or unconditional branch instruction. So if it is an unconditional branch instruction, how the target address will be calculated, or if it is a conditional branch instruction, how the condition code will be checked. So normally when we are executing any particular instruction, we will be coming across with the two phases. The first phase is called as a fetch phase and another one is called as an execution phase. So here step number 1, 2, 3 indicates it is a fetch phase. So these three steps is going to say about the fetch phase. So fetch indicates that we are going to fetch the instruction from the memory. So next is two steps, that is step number 4 and step number 5. It is about execution phase. So now after fetching only we will come to know whether that instruction is a branch instruction. So the declaration means we will be coming to know whether that instruction is a branch instruction or not. So what are the normal steps to fetch an instruction from the memory? So the normal instructions, the normal steps that are required for fetching any instruction from the memory is, so we require the address of that memory location where the instruction is available. So in order to do that, it is required that we need to enable few of the control signals. So and even we need to copy the address from one register to another register. So say for example, so program counter is a register that is going to keep track of the address of the instruction that needs to be executed. So hence the content of the program counter needs to be copied to the memory address register, wherein memory address register is connected to the memory address bus. So in order to read the instruction from the memory location, so we need to assert a read signal. So ultimately after reading, even we need to update the content of the program counter. So always while at the same time, while parallelly fetching the instruction from the memory location, at the same time the content of the program counter is going to get incremented by a certain value. So say for example, it can be incremented by value 4. So now with respect to the fetch phase, so let us discuss the first step. The step number 1 is it is copying the content of the program counter to memory address register. So if the address needs to be copied to the memory address register, so then PC out control signal must be equal to 1 and memory address register in must be equal to 1. So this copies the content of program counter to a memory address register and it is made available to the memory address bus. So parallelly, simultaneously, at the same time we are going to enable the read control signal, so in order to fetch that instruction from the desired memory location. And even we have a select 4 signal, so this also becomes equal to 1, so which is going to update the value. So now here let us consider we have a constant 4 value. So now select is equal to 1, so making select is equal to 1, so this becomes 4. So now, and even we have program counter, let us consider this as a program counter. The content of the program counter will be available. So now we are going to add with the help of the add signal. So we will be adding the content of the program counter with a 4. So now this is going to give a 4 value for an operand A, and this bus, internal bus, is going to carry the value of the program counter. So B operand is having a value now PC. So 4 plus PC, it becomes PC plus 4. So this PC plus 4 can be stored in the Z register by enabling Z in control signal is equal to 1. So this is going to happen in the step number 1. So making Z in is equal to 1 by enabling the add control signal. So here we have, let us consider we have an add control signal. So when make add control signal is equal to 1, PC plus 4 is going to get updated and ultimately it is stored in the Z register. So now, so this completes updating the contents of these 3 control signals. Update the program counter value by a new update the content of the program counter value. So now making Z out is equal to 1. So now here we have Z out. Z out is a control signal. So making Z out is equal to 1, the content of the Z register will starts to propagate here in the internal bus. So and making PC in is equal to 1. So the new value of the program counter, so this new value, updated value, will get stored in the program counter. So let us consider we have a program counter register over here. So consider this as a program counter register. So this new updated value will get copied into the program counter. And at the same time we are going to copy that value in a Y-in register, that is Y register. So by enabling Y-in is equal to 1, so that updated program counter value, even it is copied in a Y register. So this Y register content will be helpful when we have a branch instruction. So at the same time waiting for memory function completed becomes also equal to 1. So waiting for whenever a memory function completed signal becomes equal to 1, automatically the instruction is being fetched from the memory location and it is stored in the memory data register. So hence step number 3 says, so from the memory data register we can copy it into an instruction register. Hence the required control signals are MDR out and IR in. So MDR out is equal to 1, copies the content of a memory data register to the instruction register by making instruction register IR in is equal to 1. So now the instruction is fetched and it is stored in the instruction register. So now once the instruction is stored in the instruction register, it is decoded. So by decoding we will come to know that whether that instruction needs to be whether that instruction is an branch instruction. So if at all it is a branch instruction, so we are supposed to calculate the target address. So now at the beginning of the step 4 we will come to know regarding the instruction register whether it is an conditional branch instruction or unconditional branch instruction. So whatever the steps we are discussing, the control sequence that is going to implement an unconditional branch instruction. So here the processing starts with the fetch phase. So this phase is going to end when the instruction is loaded into the instruction register, that is in step number 3. So we can whenever that is once the instruction is loaded in the instruction register, the fetch phase is going to get end. So now the instruction register needs to be decoded. So therefore when we are decoding we will come to know that whether that instruction is a branch instruction. So if it is a branch instruction, then the offset value needs to be extracted from the IR register. So that is the offset value is extracted from the IR by the instruction decoding circuit, which is also going to perform the sign extension if required. So depending upon the size of the register, so even it is going to give the sign extension for the offset value. So here, since the value of the updated program counter is already available in a Y register, the offset X is gated onto the bus in step number 4 and an addition operation is performed. So the result, which is a branch target address, it can be loaded into the program counter in step number 5. So what it says that at a step number 3 or at the beginning of the step number 4, so we can extract the offset value. So when we come to know that that instruction is a branch instruction, so then if it is a branch instruction, so we are supposed to move to the branch target address. So we can move to the branch target address by adding an offset value to the content of the program counter. So make sure that when we are adding a program, when we are adding an X value, that is an offset value to the program counter, the content of the program counter must be an updated value. So whenever the current instruction is in the execution phase, then program counter will be pointing for the address of the next instruction that needs to be fetched. So therefore the program counter contents is an updated value. So program counter will be pointing for the address of the next instruction. So for the updated program counter we are supposed to add the offset value. So here the updated program counter value will be copied in an Y register. So therefore here the content updated program counter, after adding PC plus 4 we are going to store that value in a Y register. So in a Y register we have an updated program counter, so also it is stored in the program counter register also. So both the at both the places, so at Y register as well as at the program counter register we have PC plus 4. So this is going to hold the value PC plus 4. So it is an updated program counter, and here also we have PC plus 4 updated value. So now what the step number says that we are supposed to calculate an offset, means we are supposed to calculate the target address. So in order to calculate the target address, so that X value, offset value, it is extracted from the instruction register. What is the offset value? So that offset field of IR out. So from the instruction register we are supposed to only extract the offset field. So that has to be taken out, and making add is equal to 1 and Zin is equal to 1. So here the program counter contents will be made available here. So now rather than, so now we have here, this is going to give a PC plus 4. So we have a PC plus 4 over here. So this makes PC plus 4, A operand becomes PC plus 4. By making offset field of IR out, IR register is open now, the offset value will be propagating now in the internal processor bus, so hence it can reach to the B register. So here because of IR register is open, we can get the offset field, from the offset field we can get an offset value X. So that becomes a B operand for an ALU, and one more operand for an ALU is A, that is obtained by PC plus 4, which is stored in the Y register. So now PC plus 4 and it is an updated program counter value. For that we need to add an X value, which is an offset. So hence we have an add control signal becomes equal to logic 1. So now we are going to get PC plus 4 plus X. So this is the target address. So this target address will be stored in the Z register by making Zin is equal to 1, which is going to happen in step number 4. So and at a step number 5 we have Z out is equal to 1. Make Z out is equal to 1. The content of PC plus 4 plus X will be propagating in the internal processor bus, and we are going to store it in a program counter. So now the new program counter, so this becomes, so as the value is going to get copied in the program counter, so therefore we have PC plus 4 plus X value. So that is offset is also added, and the program counter is loaded with the branch target address. So this is going to happen in the step number 5. And finally end. Whenever end control signal becomes equal to 1, it indicates that new fetch operation is going to happen. So that is from the target address. So the target address is now available in the program counter. From that target memory address we can fetch the instruction that is available in that target address. So that is the step number 1 is going to get repeated. The same steps are used. So the result, which is the branch target address, it is loaded into the program counter. That is going to happen in step number 5. So this is regarding when we have unconditional branch instructions. So how the sequence of steps are going to get executed when we have an unconditional branch instruction. So now the offset value, we are considering a X, right? So that is an offset value. So what is this offset value? So this offset X, it is actually the difference between the branch target address and the address immediately following the branch instruction. So address immediately following the branch instruction means whenever the current instruction is the branch instruction, the next address will be the one more that is it has to take the difference between the target address and the address immediately following the branch instruction. So that two difference it is going to take, so that becomes the offset value. So target address minus the current program counter address. So for example, if we have a branch instruction at a location 2000 and if the branch target address is 2050, the value of x becomes 46. So now whenever the branch instruction, so say for example we have a branch instruction at an address 2000. So when we have a branch instruction at an address 2000, so program counter will be pointing for the address of the next instruction. So that is updated program counter address will be, it is 2004. So therefore what it says, x is equal to, it is target address minus next that is address immediately following the branch instruction. So what is the target address? So target address is 2050 minus 2004. So 2050 minus 2004 will become how much? It is 246. So 2050 minus 2004, it becomes the 46. So x is equal to, now x is the offset value, so x offset value is calculated in this way. So we are going to get 46. So whenever we are adding here program counter contents, updated program counter contents plus x, so what is PC plus 4? So here PC is 2000. So 2000 plus 4 plus offset value. So PC is how much now? It is 2000. So 2000 plus 4 is 2004. So 2004 plus 46. So it becomes 2050. So 2050 will be the branch target address. So now let us check with the conditional branch. So we have discussed how the operation takes place under unconditional branch. So similarly we will discuss regarding conditional branch. So in case of conditional branch, we need to, whenever we are executing a conditional branch instruction, so it will be always checking for the condition. So that condition will be reflected in the condition code flags. So we need to check the condition code flags before loading a new value into the program counter. So second point says that in this case we need to check the status of the condition code before loading a new value into the program counter. So say for example we have a branch on negative. So whenever branch is less than 0 instruction, step number 4 in a figure is replaced with this value. So offset field of IR out comma add comma Z in comma if n is equal to 0, then end. So what it says that whenever we have a conditional branch instruction, it will be checking for the negative flag. So that is, say why? Because the condition is branch on negative. So branch on negative meaning is that n flag must be equal to 1. So if n flag is equal to 0, then we are going to end. So thus if n is equal to 0, the processor is going to return to the step number 1 immediately after step number 4. So if n is equal to 1, step 5 is performed to load a new value into the program counter. So thus performing the branch operation. So only branching takes place if at all the condition is satisfied. So when the condition is going to get satisfied, if n is equal to 1, then the program counter will be loaded with a new target address. So that is, if n becomes equal to 1. Here in this example we have taken a negative flag. So whenever we have a negative flag is equal to 1, it indicates that a particular condition is satisfied. That is, negative flag becomes equal to 1 indicates a condition is satisfied. Whenever a condition is satisfied, we are going to load a target, we are going to load the new calculated target address onto the program counter. So if condition is not satisfied, so whenever a condition is not satisfied indicates that n becomes equal to 0. So if n is equal to 0, then it is not going to fetch that instruction from the new target address. So it will be repeatedly doing, means if n is equal to 0, the processor returns to the step number 1 itself. That is, it is fetching the next instruction after that branch instruction. So that is, it goes to step number 1. So suppose if we have a conditional instruction, so then we are going to perform step number 4 and 5, calculating the new target address, so and loading the program counter with a new target address. Suppose if it is a conditional branch instruction, so if the condition itself is failed, then no need of calculating the new target address. So hence step number 4 and 5 operation is not done, because no need to, if the condition is not satisfied, then no need to calculate the new target address. So hence what it is going to do, it is going to begin from the step number 1. So until the condition is satisfied, it will be keep on doing the same work. So this is regarding conditional branch instruction. So conclusion is, we have discussed execution of a branch instruction with respect to unconditional branch instruction as well as conditional branch instruction. So we are going to follow the same sequence of steps in order to fetch an instruction. So once we are going to fetch the instruction, after decoding the instruction, we are going to get the offset value. The offset value will be added to the program counter contents in order to get the new target address that will be loaded onto the program counter register. So the instruction fetch begins from that newly target address. So from that address the instruction fetch begins. So this is going to happen in case of unconditional branch instruction, whereas when the branch instruction is of a conditional one, it is going to check for a particular condition. So if at all the condition is satisfied, then only the offset value can be added to the content of the program counter, and hence the new target address can be calculated. So if the condition is not satisfied, then it will be again moving for the step number 1. So these concepts are discussed in this particular lecture. Thank you.